So this video is going into the history of the atom, just a couple scientists, a few scientists that we focus on in the first year of chemistry. So we are going to focus on Dalton, okay? And you might want a highlighter for this, just so you could kind of focus on a couple things. So we're going to talk about Dalton. We're going to talk about JJ, one of my favorite, JJ Thomson, and then Rutherford. Okay, so those are going to be the three that we focus on. So Dalton is credited with what we call atomic theory. So write down atomic theory. So there are four major points to his atomic theory. First point is all elements are composed of atoms. And really the purpose of us going over the history of the atom is just so that you can see essentially that we are, our models keep changing. So that we have to be mindful of the fact that when we are using these models, that history of the atom itself, every model kept changing once they kept getting more and more information. So when we say all atoms are composed of atoms, in the 1800s, when this was kind of proposed, nobody had really stated that. So again, I know we probably are like, yeah, of course we know that, but they didn't know it at the time. And more specifically, they said that the atoms were indivisible. So highlight the word indivisible, meaning it can't be divided any further, okay? So the atom was supposedly the smallest thing, but we know the protons, we have neutrons, and we have electrons. So we know that that is no longer true of Dalton's model of the atom. We have smaller things than that. So Fermilab, argon, any particle accelerators, they were talking about what makes up a neutron, what makes up an electron, quarks and other weird things that they are discovering in recent times. So again, the model keeps changing as we get more and more information. Number two, atoms of the same elements are identical. So that is due to the number of protons. So if I have 7 protons, I have to be nitrogen. If I have 8 protons, then I am oxygen, and so on and so forth. So the identity of the atom is going to be the same. It's going to dictate by the protons. Atoms of different elements can combine physically or chemically to form compounds. So at the time, they really thought that you could just put things together and they would become compounds. They didn't quite understand that there had to be a chemical reaction. Energy needed to break bonds, make new bonds. So again, we're going to just cross out physically, but that's really what they thought. They could just put two things together and it would make a compound. But really, it needs to chemically combine in such a way to make a compound. And finally, the atoms of one element can never change into the atoms of another element. That's no longer true. In particle physics, quantum mechanics, we now look at it as like a general term. We could say nuclear chemistry. You could bombard something with a neutron and change it. The alchemists from history used to be the first chemists, essentially. They were taking metals and changing them into gold or changing them into silver and trying to sell them, or say that, oh, look at my abilities here. But we know them now not to be true. But we now have the technology to actually change one element to another. We have on the periodic table the elements that are on the bottom here. These are what you call made elements in the lab. So we can put protons and neutrons together and make something completely different. So that is not true of Dalton's theory. But Dalton is credited with getting a lot accomplished, essentially, in his atomic theory. So next is going to be JJ in cathode ray experiments. So J.J. Thomson is credited with this experiment called the cathode ray. And this is actually, the cathode ray is from old style TVs, used to be made up of cathode rays. So if you look it up on the internet, that's will probably be one of the references that you see. So what you have here is, this is a glass tube. Okay, this is a glass tube. And you are sending electricity. Okay, so if you want to label this as electricity, we are sending electrical current through here. And it's called a cathode ray because we have a positive and a negative end. Essentially, these are metals, okay? These are metals that you have placed into this glass tube that has essentially a vacuum. So there's nothing else going on there. So the electricity is hitting the metal, and so you're generating a beam. Okay, so this arrow here is a beam of light. And again, watch the other video so you could see it live and in person. So what Thomson noticed was once he created this beam, if he put metal plates that had positive and negative charges close to the beam would always deflect towards the positive metal plate every time he did this experiment. So even if he changed the metals here, he saw the same behavior over and over and over again. So he said there had to be something in this beam that was attracted to a positive. And of course, they understood negatives, positives liked each other. So therefore, that was what they went off of. So if you want to put some bullet points underneath this, this is what I expect you to know. That this is a glass tube, which essentially has a vacuum. So there is nothing in the tube itself, okay? You send electricity through it, through metals. And what Thomson did was he did multiple metals, different experiments to prove that it happened no matter what metal he was using. So it created a beam, and this beam was then put in essentially a magnetic field. So you put magnets up to that beam, and it was always attracted to the positive magnet. So the positive end of the magnet, it kept being attracted to it. So this beam kept doing this over and over and over again, no matter what metal he used. So therefore, if you've seen these three dots before, it means therefore, something in that beam has a negative charge. Because if it kept being essentially attracted to the positive magnet, there had to be something negative in that. So he is credited with discovering the electron. Did he come up with the term electron? I don't believe so. I think it was a combination of people. But he is, again, given credit for the fact that he discovered the electron. No matter what metal he put in there, he saw the same behavior.